Friends, this is probability and stochastic process. Stochastic process, and I'm Smith, and this is homework 7, question 7. So in question 7 we are given a z of t, and in the given z of t, theta is uniformly distributed in 0 to 2 pi range. N1 and N2 are Whiteson's stationary. N1, N2 and theta are all independent. So first question is, we need to find the expected value of z of t. So before finding the expected value of z of t, let's try to assume something, that the expected value, as n1 and n2 are WSS, that is Whiteson's stationary, the expected value of n1 of t is, let's say, some constant function n1 for convenience, and second is expected value of n2 of t is n2, suppose. So expected value of z of t is, this is n1 of t and this is n2 of t. So expected value of entire function z of t, so that is n1 of t into cos omega ct plus theta plus n2 of t sin omega ct plus theta. This is nothing but expected value of n1 of t. We just found out this one, and multiplied by expected value of cos of this function. So in order to find the expected value, we know that the theta is uniform in the range 0 to 2 pi. So let's try to average it over the range, over its entire range from 0 to 2 pi, and integrate it. So similarly for the next term, similarly for sine function, so we know that this function, due to the symmetry, the value, its value over the entire region is going to cancel each other, the positive and the negative part, due to the symmetry. So its integral over the entire range from 0 to 2 pi is going to be 0. So this is 0 and this is n2 into 0. So this is 0. So expected value of z of t is 0. Second part is, we need to find the autocorrelation at time t1 and t2. And we also need to say that if z of t is WSS or not. So for that, let's try to find the autocorrelation first. This is just comma. So Whiteson's stationary. Now this autocorrelation is given as the expected value of the same function at two different times, the multiplication. It's just the product of the expected values. So to find the autocorrelation of z, we just need to find the product of its expected values at time t1 and t2. So this is E of z of t1. Z of t1 is n of t1 sorry, it's not n1, it's n at t1 time into the entire function at time t1 and t2, and it's just product. So let's try to do that quickly. This is multiplied by just the same function but at time t2. This is time t1, this is time t2. This is, yeah, this is n1 and n2. Yeah. So we will have the four terms. We will have the four terms now, that is n1 t1, sorry, let's cancel this step. Now we need four terms that are just the products of the two brackets earlier. We are just multiplying the two terms at the same function at different time, that is at time t1 and t2, and we have this four terms. This is a bit tedious, but we need to find it. So expected value of n1 at time t1 multiplied by expected value of n1 at time t2 is nothing but the autocorrelation at time t1. So this is let's say the function of r1, that is the autocorrelation at time at different time t1 and t2, that is this function of tau of 1, let's say, and this is multiplied by, and we know this, we need to integrate over its entire range where it's uniform. So Now here we can see that we have this four functions, this four terms I mean, and this is going to cancel each other out, and we know that this is an even function, so it's going to be 0 anyway. So finally we have 1/2 Rn1 of tau into cos omega c tau. Tau is just an intermediate variable that we are using here. So now we have something like this, and we can, let's take cos omega c tau common from both, so it's just nothing but r1 plus r2 of tau. And from here we can easily say that z of t is WSS, because this is going to be a constant term, this is a constant value, and 1/2 is also common because is also constant. So we can say that z of t is an wide sense stationary, as its expected value is WSS, as its expected value is constant. Is some constant. And we also need to find our z of 0 if z of t is given to be WSS. So if z of t is given to be WSS, then our z of 0 would be 1/2 cos of omega c into 0 into Rn of 0 plus Rn2 of 0. So this is nothing but 1/2, and cos 0 is 1. And this is nothing but the expected value of n1 t plus expected value of n2 n over t. So this is the RZ of 0. So this was homework 7, question 7. Thank you.